Fermi distribution function. Fermi distribution function is a probability function of an electron occupying a given energy level at absolute temperature. It is used to find the probability of finding a particle. It is expressed by an equation f of e is equal to 1 over 1 plus exponential of e minus ef by kt. Here the E is the energy level whose occupation is being considered, and EF is the Fermi energy, K is the Boltzmann constant, and T is the absolute temperature. As we know that it is a probability, the value varies from 0 to 1. If the f of E is 0, the particle is not present. If f of E is 1, there is 100% chance of finding a particle, and if f of E is 0.5, there are 50% chance of electron occupying in that particular energy level. With the help of this Fermi distribution function, we can calculate the probability density of finding a particle in a particular energy level. Effect of temperature on Fermi function. As we know that f of E is equal to 1 over 1 plus e power e minus ef by kVt. The first graph shows x-axis energy and y-axis the Fermi function. At 0 Kelvin, the energy levels are filled up to Fermi energy level completely. That's what, up to the Fermi level at 0 Kelvin, the probability is 100%, that is 1.0. If beyond the temperature 0 Kelvin, as we increase the temperature, some of the electrons may be excited to the higher level, so the Fermi level shifts. There may be some deviation in the Fermi level. As at higher temperature, more than 0 Kelvin, the Fermi energy level further shifts down. That's what the probability becomes 0.5%. If the energy level is below the Fermi energy level at D0 Kelvin, by substituting here, E is less, so E power is less, E power negative value, E power negative values equal to E power minus infinity is 0, so we have f of E is equal to 1. There are 100% chance for the electrons to occupy the energy levels below the Fermi level. As we know, the Fermi level is the uppermost completely filled energy level by the electrons. So below this Fermi energy level, all the energy levels are filled. That's what the probability is equal to 1. If the energy is greater than Fermi energy, so E becomes E power positive value, E power infinity is infinity, so we have Fermi f of E is equal to 0. So above the Fermi energy level, the probability is 0. There are 0% chance for electrons to occupy energy level above the Fermi energy level. All the energy levels above Fermi energy levels are not occupied by the electrons. At ordinary temperature, the value of probability starts reducing from 1 here, 1, and it is reducing up to 0.5. With increase of temperature, that is above 0 Kelvin, the Fermi function varies as temperature increases. The Fermi level shifts, which is indicated by this graph. When the energy is equal to Fermi energy level, by substituting the Fermi distribution function, we can get 50%. There is 50% chance for the electrons to occupy at Fermi energy levels. So that's why f of E becomes 0.5, half. At high temperature, kT is very much bigger than Fermi energy. As the temperature tends to 0, the electron lose their quantum mechanical character, and Fermi distribution function reduced to classical Boltzmann distribution. Thank you.